Dane Vas. Today we will solve a problem a different way. We will solve this integral. Integral of sine of x plus 2 cosine of x divided by 3 sine of x plus 4 cosine of x dx. Using a difference method than what was presented in another video, link in description to below, we will do this two ways. We will use Harmonic Sum Theorem, which allows us to rewrite the sum of sine and cosine in terms of a singular sine function or a singular cosine function. And we can do this either way. I'll do two separate videos. There will be a link to the sine video in the description below. So how would we approach a problem like this? I would say that the first thing we want to do is use properties of trigonometry to simplify it. That's why we have this harmonic sum theorem, to simplify what we have here. There will be, of course, a detailed version of how I derive the equation and links to other people that do it as well in the description below. But I think if we do it this way, it allows us to avoid Wierstrauss substitution and allows us to avoid linear algebra here. We can just use simple properties from trigonometry to simplify this, and I think that would be easier. So we're going to apply this harmonic sum theorem to top and to the bottom. Okay? And recall that for the harmonic sum theorem, our a is square root of a squared plus b squared, and then the tangent of the angle phi is minus a divided by b. Now, in this situation, we have an invisible 1, so that will be our a, our b will be 2, and for the bottom angle, a will be 3 and b will be 4. Okay. And because we're choosing the angle that is in the range of the inverse inverse sine function, from negative pi divided by 2 to pi divided by 2, a will always be positive, although there's infinite number of solutions for this one. So let's set this up and let's set up our triangles before messing around with this problem. We'll set them up like so. We'll give angles names. I'll name the top angle phi and the bottom angle alpha. And so for that, we have tangent of phi is negative 1 divided by 2. So for this angle, that's going to be, we're going to have the side opposite be 1 and the side adjacent be 2. So like so. That places us in the fourth quadrant like this, and that becomes angle phi, like that. And for another angle, we'll use a blue color. We'll have the same situation that happens. This is 1, 2, 3, 1, 2, 3, 4. Like that, places us again in fourth quadrant. And so that will be angle alpha. Alright, and that's going to be 4, and that will be negative 3. That will be 2, and that will be negative 1. And we recognize immediately that we have Pythagorean triple here for the second angle, alpha, so this is going to become 5. And if we quickly do some arithmetic, 1 squared, negative 1 squared plus 2 squared, that gets us square root of 5. Alright, we now have all pieces that we need so that we can solve the problem. So let's apply this harmonic sum theorem. The first thing that's first is here, that integral of sine of x plus 2 cosine of x over 3 sine of x plus 4 cosine of x dx now becomes integral a squared. A is 1, b is 2, or a is negative 1, doesn't really matter. Either way, you get square root of 5 for the top, cosine of x plus phi for our first angle. And then on the bottom, we have, of course, 5 cosine of x plus alpha. And this is all still with respect to x. Now that we've done this, we have it nearly in a form where we can solve the problem. The problem now is that we have two different angles in phase shift, and we have to fix that, and we can fix that by u substitution. So if we let u equal x plus alpha, we know that du will equal dx immediately. And of course, we can solve the second equation in terms of x. X will be u subtract alpha. All right. And we can take this information and plug it in. Because square root 5 over 5 is constant, we factor that out. Cosine of x in this case is u minus alpha. So we'll plug that in. This becomes u. And I'm going to put the phi, I'm going to put plus phi first, and I'm going to subtract alpha here, and you'll see why in a second. And I'm going to put a parentheses around it, like this, because that's going to make it clear what's happening. And then we'll divide by cosine of u. And this is now du, like this. And now from here we use the sum formula for cosine, which we can immediately recall what that is. Cosine of u plus v, different u, it doesn't really matter. It ends up equaling cosine of u cosine of v minus sine u sine v. And we applied that here. And because we're also dividing by an individual cosine, we can split this. So this becomes square root 5 over 5 integral cosine of u cosine of phi minus alpha minus sine of u sine of phi minus alpha, all divided by cosine of u du. From there, we can split this off, and we can distribute the integral sign, so the integral sign gets distributed there, and the du gets distributed here and there. And so now, this whole mess becomes the square root of 5 over 5 integral cosine of u, and I'll show you the cancellations, and cosine of phi minus alpha subtracted from, and remember, numbers get jealous, so we'll distribute that square root 5 over 5, integral. The minus sign's already factored out, so it becomes sine of u, and I'm not going to actually simplify this to tangent here, and you'll see why in a second. Although I could simplify it here. Alright, so now we have the integral set up the way we want. From here, what we do, cosine of phi minus alpha and sine minus phi minus alpha are constants, so they can be factored out. Cosine simplifies. And so now from here, we have integral of du. We can actually just straight integrate from here. And so we have square root 5 over 5 cosine of phi minus alpha, which is our constant, and then we'll integrate with respect to u. And of course, the integral of du is just u, and that can be left alone. And then this becomes, of course, minus square root 5 divided by 5. This is a u substitution here, although we're going to do it in our head. And if we do the u substitution in our head, that will be negative. That becomes z equals cosine of u, dz is equal to negative sine of u du, and then du is equal to dz is equal, du is equal to dz divided by negative sine of u. So that changes the sign here to positive. And so that changes here the sign that's outside here to positive. And then I already know what that integral will be. 1 over z is ln absolute value of z. And so that becomes phi minus alpha. And so that integral becomes ln absolute value of cosine of u. Like so. Alright, from here, what do we know? We know the value. We can use the properties of sine and cosine to simplify the phi minus alpha part. So let's do that. Okay, recall cosine of phi minus alpha is the same equation. Cosine, cosine, sine, sine, but the signs flip. And then for sine, it's sine, cosine, cosine, sine. And the signs stay the same. Alright, so from here, we use those formulas. Square root 5 over 5, cosine phi cosine alpha minus sine phi sine alpha in the parentheses, because I don't want to distribute, times u, plus square root 5 over 5 sine phi cosine of alpha minus cosine of phi sine of alpha inside parentheses times ln absolute value of cosine of u. We'll put everything in x at the end. So we know the values of cosine phi and sine of alpha from our triangle here at the top. We can see here immediately that cosine of phi is 2 divided by square root 5. Cosine of alpha is 4 divided by 5. And then we know from here sine of phi is negative 1 divided by square root 5. And we know from here sine of alpha is negative 3 over 5. From that, we can plug these numbers into equation. And once we plug these numbers in, cosine of phi is 2 divided by square root 5. Cosine of alpha is 4 over 5. Minus negative 1 over, I think that's a plus. There we go, plus there, and so it's minus 1 over square root 5 times negative 3 over 5, which, after a bunch of simplification, 8 plus 3 is 11, and 11 over 25 square root 5 becomes 11 over 25. So, that becomes 11 over 25 times u. U, recall what that is from our equation, is x plus alpha. And we know alpha is arctangent of negative 3 divided by 4. So we'll plug that in. This becomes x plus arctangent of negative 3 divided by 4. And we're done with this piece of the puzzle. Times u. Alright, so times that. Now that we've done that, we do the next piece. Sine, cosine, cosine, sine. So, very quickly, plugging in, sine of phi is negative 1 over square root 5. Cosine of alpha is 4 divided by 5, minus parentheses, and then we end up with cosine of phi, which is 2 over square root 5, times sine of alpha, which is negative 3 over 5. And so that ends up with negative 4 minus a minus 6 becomes positive, and so minus 4 plus 6 is positive 2 over 5 square root 5. And so this ends up simplifying, becomes 2 divided by 25. And this becomes ln of cosine of x plus arctangent of negative 3 divided by 4. Alright, now we are in terms of x. For everybody, arctangent of negative 3 divided by 4 is a constant, and so is 11 over 25. So we're going to drop that constant, and it becomes 11 over 25. X plus 2 divided by 25, ln, absolute value. I can rewrite the cosine as 3 sine of x plus 4 cosine of x, or I can leave it as this. It doesn't matter. No one's going to judge you if you leave it as this. I will rewrite it so that it matches the solution on the other video. This becomes 3 sine of x plus 4 cosine of x plus c. And that is it with integration. Hopefully the process made sense. And if you would like to consider a subscription to the channel, that would absolutely be wonderful. And I hope for you guys to have a good day.